Hi everyone. Today we're going to be talking about sexual selection. So this is one of the 5 forces of evolution. I'm assuming you probably just watched that particular PowerPoint on the 5 forces where we talked about the first 4 in more detail, and then the 5th one, sexual selection. I kind of just told you the name and said we're actually going to be spending more time on that one with its whole own PowerPoint. So that's this one. This is probably one of the longer PowerPoints for this whole class. If I were teaching this in class, it would take us a while because there's a lot of little videos and stuff that I would show you, but obviously you can watch those on your own time. I have a list of a few in here. As we get to them, I'll kind of point out which ones you definitely should watch, that I'm like, watch this one for sure. Maybe not necessarily all of them, but as we get to them, I'll kind of point out. So let's see, sexual selection, skip through. Okay, so slide 3. I know when we go through these, sometimes I'm like, I don't want to hit every single tiny bullet point because you guys know how to read, especially on this one because it's very long. But there's also a lot of stuff I don't want to just skim over. So you'll see on slide 3, the title says female is the default. And this is important to remember for a lot of different reasons. But in terms of this class, what we mean is if we're talking about, biology, anatomy, morphology, evolution, what we mean is imagine time, like in deep, deep time, like a long time ago. Because right now, especially let's say we're talking about like humans or primates or mammals, we're talking about species who sexually reproduce. There's a male, there's a female, there's gametes, and we know how that whole thing works, right? And there's different ways that they kind of come together depending on the species. Do they mate for life? Do they only come together at certain seasons? Et cetera, et cetera. Like there's variation, all of that. It's all very interesting. We're going to get to that in a minute. But in general, though, we know that we mate sexually. So there are still some species that reproduce what we call asexually. So basically, they're all female, and they basically make clones of themselves. And there are still a handful, I think, of some reptile species that still do this. But there was a time when that was how it all worked. And so when we say female is the default, this is one of those examples that in this deep, deep, imagine, hundreds of millions of years ago, we basically, everything is kind of reproducing asexually. And so eventually, though, the male, whatever chromosome, males in general, that kind of gets introduced to the way nature works. And so what this kind of means, this kind of tells us a lot about when we're looking at nature, why it kind of is the way it is. So one example is the chromosome. So the X chromosome is very large, very well developed, very detailed. The Y chromosome is very small and not, it's not a judgment call. It's literally had a lot less time to develop, evolutionarily and whatnot. And so that's just kind of one of those examples. If you ever wondered, why is the X chromosome so complex and large, and the Y just kind of looks weird next to it, right? That's why it's had significantly more time to develop, right? But even in the body plan of what we look like as animals, whether we're talking about humans or rabbits, whatever, the female is the default body plan. It's the male body plan that's kind of a deviation from that. And of course, that kind of depends on the species, how that, works a little bit. But especially if you say have an animal species where you're looking at, they have a moderate amount of dimorphism or even a larger amount of dimorphism, what you're seeing is the female is the default version of that species. The male, through via, sexual selection, which we're going to talk about here in a little more detail. So if you're kind of getting what I'm saying now, but you're I think I need a little more info, it should be clear as we kind of talk about this. But basically, when we're talking about sexual selection and how the males in certain species might be a bit larger, more colorful, etc., that's a deviation from the default. They're not the default, right? So in how we kind of think of things genetically, visually, on how animals actually look in their phenotype, all of that stuff, deeper time, reproduction, gametes, it all kind of comes back to this idea that the female in multiple ways is the default for all of that. So keep that idea in mind, because it's going to help kind of guide you with understanding a lot of this, right? Okay. Let's see. I got a couple quotes. Skip that. It's fine. Okay, so this is one thing that's very important in science, not even just this class, but in science in general. definitions are very important. Standardization of like terminology, it's all very important. So we make sure we are all understanding the same thing. When I use a term, when you use a term, we know we're talking about the same thing, right? This is true for really any field. You have like a standardization of, terms. But of course, in science, this becomes even more important for like accuracy of data and whatnot. And so there are two terms I have on slide 5, sex and gender. In this class, we're going to be talking just about sex. I also teach the Anth 101 where we have really interesting conversations about sex and gender. So that's, something for another class. In this class, because what we're talking about is the evolutionary process, reproduction, biology, anatomy, gametes, etc. That's just purely sex, not gender. Now, unfortunately, in our society for, decades and decades, people like to use the word gender as interchangeable with sex, but they do mean very different things, right? People don't like to say the word sex. But we're all adults, right? We can say the word sex. And even here, we're not even talking about like sex as in intercourse. We're talking about just like sex as in male versus female, animals. So that's sex, not gender, right? So you see, I've got a couple definitions here. So sex, individuals are categorized as either biologically female or male based on their anatomy and physiology. And sex is a binary. So if we're talking about, let's say, humans, we would have conversations about, processes of puberty, this primary sex characteristics, the secondary sex characteristics, gestation versus insemination, etc. Like you can have that very similar conversation about most mammals, right? So that's kind of the biological stuff, right? But here we have for gender, how one views him or herself socially or culturally, or how the oppressive expectations put on someone based on whether they're born male or female, right? So even gender, we could have, a bunch of different definitions, which is why in the 101 class, we end up having really interesting, back and forth, debate, conversations. It's all very cool. But in this class, we're not talking about gender at all, right? We're just talking about sex. So just so we're clear, if you were to use the word gender, let's say I had you write like a short answer essay on the exam and you used gender, getting marked down a point or something because it's the incorrect term, right? Okay, let's see. On slide 6, you will see I've kind of given you a representation of what this looks like in terms of sex. That it's my little doodle I did in the very important software program, very, very difficult to learn. It's called Paint. Maybe you've heard of it. But you'll see here, even if you're like, I don't know how to read graphs or whatever, should be really straightforward. You're seeing it's graphed, right? But you're seeing two clusters. One's a red cluster of whatever, dots, we say individuals, animals, whatever, whatever. And then a green cluster, right? So when we're talking about the idea that sex is a binary, it doesn't mean that every single female, whether it's a human or a rabbit or a frog, whatever, looks exactly the same. Of course, that's absurd, of course, right? Variation exists. We can look at all the females, look at all of the females in your friend group. Let's say if you're a female or if you're a male, look at all the females in your family. Like, they're all female, right? But they have differences in like their hair color, their nose shape, their foot size. Like, there's just variation exists for any and every trait, right? Some of them might be slower or faster in running. Some might be, better at one skill and not as good at another. Like, that's just variation of how life works, But when we look at all females, let's say we're looking at one individual species, human, rabbit, whatever, you're going to see clearly two groupings. Females, while there's a little variation, so we don't see, they're not a single point, right? There's like, here's a female, looking at all these different traits. There's a cluster of them. The clusters will clearly be separate, right? Even when you see the occasional random, like, oh, that's a little bit of an outlier, right? Just because there might be an outlier, it's all very interesting, but it doesn't take away from the fact that the clusters are still clearly there, and even in this case, visible with your human eye. Mathematically, statistically, they would be very clearly two different groupings, right? So when we say sex is a binary, because I had one question from one student asked me this question a couple semesters ago. Well, like, if it's a binary, doesn't it mean they should be they're distinct, that they look the same? And I'm like, look around the world, look around the room, right? Nothing, that's not how life works, that's not how nature works. When we're talking about females of one particular species or males of one particular species, there's gonna always be variation, right? Not every female or every male looks exactly the same. Like, that's literally not how any of it works. So of course there's gonna be variation within those groups, but the two groups themselves are clearly separate, right? So that's, if you were wondering what that phrase meant, that's what that means. And then on the next slide, slide 7, you'll see that kind of representation, depending on your interpretation of what gender is it kind of a spectrum? Is it still kind of two clusters of masculine, feminine, right? if I were to survey everyone in this class, like, what is your definition of gender, how it works in society, da, 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 is it an oppressive force, is it a form of expression, anything and everything in between, right? We're all going to have different ways of kind of understanding that or visualizing that. So that's, like I said, in another class, we have some cool conversations about that. But in this class, slide 6 is it. It's just sex is binary. We're just talking about sex. So if you go to slide 8, you'll see a nice little list of some of these. Like I just mentioned them a moment ago, but you'll see here's a list. The biological differences between males and females. So whether we're talking about, let's say we're talking about mammals or primates right now. So this is like a biological evolutionary differences in terms of, reproduction. There are those who are going to gestate the fetus. Those are going to inseminate, right? Those are two different roles reproductively. So one requires you to be there momentarily. One requires great investment, bodily, calorically, pain, time, like the whole thing, right? So those are two, not good or bad, better or worse. It's just two very different roles reproductively. The reproductive organs are, of course, very, very different. So if you're a male or a female, the reproductive organs, if you have to gestate a fetus versus if you're not doing that part at all, of course, the reproductive organs are completely different, right? For those very separate roles. Also the sexual organs, which aren't necessarily always the reproductive organs. And in class, usually I ask the students, what is a sexual organ? What's the only sexual organ actually that's not a reproductive organ? Some will say, oh, the vagina. And I'm like, the vagina is not a reproductive organ. It's the clitoris, right? Usually it takes one of the students like 10 minutes to whisper clitoris to the rest of the class. So like that's a sex organ, but not a reproductive organ, So that's obviously different in male versus female. The processes of menses or menarche, so like the onset of menses, that's something that's a female-only experience, right? Males don't experience that in mammals. So that would be something that kind of separates the two groups. And then what we call the secondary sex characteristics. So primary sex characteristics are like your genitalia. We're looking at like external and internal. So we're looking at a male or female. It's like, okay, vulva, labia, penis, scrotum, right? The things you can visually see in that area that differentiate you from male to female, those are like the primary sex characteristics. But secondary sex characteristics are the features that develop during, kind of before, during, and after puberty. So when humans, we would say, okay, females get a period, right? Which isn't necessarily true for all mammals, but we could say, let's say we're talking about just humans in this example, there's an onset of a period, and then for the female over the course of so many years, the breasts start to become larger, the fat distribution in the lower part of the tummy and the hips starts to develop. This is also very important, and I feel like a lot of people in general don't understand this, especially young women. It's a little different generationally now, thankfully. I think as women, especially young women, are breaking through a lot of this like gendered nonsense, but it was very harsh when I was younger, in the 1990s. This idea that you have to be rail thin, I mean, it still exists. I'm not saying it doesn't, but I feel like we're having the conversations more about how it's BS, and so I remember being 16, 18, 19, and you're like, I have this little tummy, and also as you get older, you're going to be like, oh my God, when I was 20, I was so skinny. I thought I was fat. I was a dumbass. Like I'm like 3 sizes bigger now, so that's going to happen to everyone. But I remember this idea, like I have this little tummy and my stomach's never going to be flat. And then realizing later, oh, it's not supposed to be. Like evolutionarily, as a human female, it's not supposed to be flat. Some females might just happen to be that way because variation exists. But the average female state is you are going to have, as a female mammal, you are supposed to have extra fat reserve on your body, especially around basically a reproductive organ. So in that lower part of your belly, in your hips and stuff, you're supposed to have that to aid in any possible fetus that comes along. It's like an extra fat reserve of calories for that fetus. Now, you may never get pregnant, you might not decide to, it just doesn't happen for you, whatever. But evolutionarily, your body has kind of been set up that way for that purpose. So you're supposed to have that there, which is why it's so hard to kind of get rid of it, because you're supposed to have it there. So okay. I mean, I could talk about that for a while. So that's supposed to be there. So, and then males, you get more facial hair. Well, everyone gets more hair on their whole bodies, right? Of course, but males tend to get more facial hair, more body hair. It tends to be thicker and more. Male upper body will get wider, right? Their voice drops. So we are very well aware of the things that happen behaviorally, physically, physiologically during puberty for males and females, And then, of course, the hormones. We have similarities in hormones, but there's obviously different things, different levels, etc. And then, of course, the life stages. So, female humans, we are very lucky that we have some really interesting life stages. So, male humans, just like most male mammals, can reproduce basically up until they die. But for females, this is not the case. Well, in some of us. So, humans, let's see, I think as far as we know, I think if I'm remembering correctly, female humans, female orcas, and female elephants. I think it's those three are the only ones that have what we call grandmothers. Now, of course, you might be thinking, oh, well, other animals have generations of females, of course, but in this term, how we kind of define it is when you're in a period of post-reproductive life. So as the female in a particular species, you are living for an extended period of time, not just a year or two, but for decades, and you cannot reproduce. This is like very interesting evolutionarily. Only a handful of mammals have developed this ability in the females only, right? And it serves so many wonderful purposes in those species, right? So it's very rare. We are one of the species that has this ability. So for human females, let's say I think the onset of like menses, menarche is like, I think it's like 12, let's say maybe even a little younger in the US right now. So let's just say 12 years old. And then I think the average age for menopause, so the cessation of your period, so you no longer can reproduce. There's kind of a process of it happening, but I think the average age is like early 50s, let's say 52. So there's like 40 years of your life where you are able to reproduce. But then for human females, because we live on average till late 80s, you could have another 40 years of post-reproductive life. And that's only something that happens in a handful of mammal species. And the others, once the female, like you basically, it's the same as males. Like once you kind of are able to reproduce, and once you kind of stop being able to reproduce, you die, like males and females, right? You can kind of reproduce up until your death. But for humans, we have this long extended period of where that doesn't happen. So that's something that only females have, not males, right? So very interesting. So kind of separating once again, male versus female. Oh man, there's so many slides on this PowerPoint. Two types of sexual selection, inter and intra. So this is either between the sexes or within. So between, like, what are the scenarios and interactions between males and females in terms of sexual encounters, reproduction, courting, all of that stuff. And then intra would be within the sex. And 99.9% of the time, we mean between the males. Like what's happening within the males amongst each other that affects reproduction in some way. So typically this is almost always represented by the males are competing with other males over access to females. Females aren't competing with other females over access to males. That's just not how it works in nature, right? You might say, well, I knew a couple women, humans, who that happened with. Well, that's just anecdotal. And in terms of the species at large, or primates at large and mammals at large, that's not how it works. And that's why when it does kind of happen, it's weird. It doesn't seem natural because it's not natural. So males are the ones who compete with other males over access to females. Females kind of just get to choose which males they want, right? Pros and cons, it's, and levels of how this might work depending on the species, of course, but that's kind of the general idea. So males will often compete with each other with certain behaviors, certain parts of their body they use as weapons, teeth, horns, etc. Depending on the type of species, they will fight with each other. Maybe there's a dance they do or a song they sing. Like it just depends on the species, but they will be competing with each other over access to the females in some way. Let's see. I think I'm kind of repeating myself for a couple slides. So if you go to slide 13, you will see there are 3 videos. There's like links to these videos. I will go ahead and watch those. They're all a couple minutes each, but they really show you some interesting sexual selection examples. The first one is about the bowerbirds. If you don't know what bowerbirds are, they're incredible. They're the ones who build these what are called bowers. They spend like years building basically like this giant kind of nest. But it's not really a nest. It's kind of like a little apartment. And the female will come along and choose which one she likes the best. And they decorate it with like flowers and stuff. It's very beautiful. And the females will come along and kind of, what's the word I'm thinking? Not investigate, but like which one do I like better? And then she'll choose the one she wants to mate with based on his ability to, presentation. It's all about presentation. So that's very interesting. The sage grouse, there are these these birds, and the males are very large. There's a lot of dimorphism between these. The males are much larger than the females, right? And so, but they'll walk around and they're like, blue, blue, blue. They have this big like air sac in like their chest, and it goes blue, 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 blue. And the females are like, like watching, like, okay, which one's got bigger? Which one did it the best? Who had best repetition? Like these are the things, they're kind of judging it on. And for the sage grouse, though, let's say there's like 100 females and 100 males at like the mating area. It's called a lek, where they like meet and stuff. The males kind of perform, and the females are like, which one do I like? It'll only ever be like, I'd say out of 100 males, maybe like 5 or 6 that actually get to mate with the females. All the females end up getting to, mate, but a lot of them won't even get to mate. And so it's very obvious that the female, grouse is seeing something in these males that they like, because for the sage grouse, they're not mating for life. They're not monogamous at all. So they're basically, I'm only going to interact with this male for this moment. So they're really picking and choosing, like, okay, I need to pick whatever trait they find as a sage grouse they find attractive, right? Whatever, and they're like, okay, what are the traits? Because I'm getting from this individual is like just this genetics, right? They don't think this in the forefront of their mind, right? But we don't either, we'll get to that in a minute too. But, so they're just, whatever they find attractive, they're picking on, which usually is representative of something really important about the individual's behavior, health, etc. So yeah. And then the Darwin's beetle is pictured there. They kind of fight with each other to climb up the tree. I would spend the time, the couple of minutes to watch those videos. They're very good. Kind of similarly on the next slide 14, there's another short video. I think that one's probably about 8 or 9 minutes, but it also gives a few more examples of, animal mating. That one's a little more fun. There's this one, it kind of shows like this, I think it's like a tarantula, and oh God, who narrates it? I want to say it's like, I don't think it's Benedict Cumberbatch. Oh, he does one. It's like these the kiwis, they're like chasing each other. That one's cute. But then there's one about like wolves, and there's one about tarantulas, and it's like very seductive, and like, it's like, the male tickles the female with, like, it's just so good. You got to watch this one. It's a few minutes. You got to watch it. It's really good. And here on the next couple slides, we actually have some interesting human examples. So you will see on slide 16 and 17, it's a very similar image, but it is slightly different. And it's showing you this example of what we call the waist to hip ratio example. Now, these two images have been shown. This is a well-known study where multiple heterosexual men have examined this from like different ages, different populations, cross-culturally, and most of the men will select, when they're asked, which of the females do you find more attractive? Now, if you're looking at slide 16, you'll notice all 3 of them, she's kind of a smaller, more petite female. In slide 17, she's a little bit more of an average-sized female. So it's not to do with like the general size of the woman, but kind of in the title of the slide, they're looking at the waist to the hips. And you'll see that in slide 16, whether she's a size 6, or in slide 17, where maybe she's like a size 12, that the waist is very defined in the first individual in the image, right? Whereas in the other two on either slide, it's not very defined. And this is a really important feature that when you ask most men, when they're looking at women, pictures of women, like, which one do you find more attractive? In the forefront of their mind, they're just like, oh, it's instinctual, right? Like that one, A or B or C. And most of them will agree. You might have some who are like, oh, I think B is more attractive because, once again, variation exists. But most of them will select one, either from slide 16 or slide 17. They'll select the first image. It's because that in that image, the first individual has a more distinct difference between the waist and the hips. And what this is telling us is evolutionarily, there's a lot more going on. So the males in the forefront of their mind aren't like dissecting, like now you might dissect it, right? Like, oh, why did I select that trait that I liked? It's because you realize, or, what's really going on is it's giving you really important information as a heterosexual male. One, it's telling you she's post-puberty, right? So she's sexually available. She has, the secondary sex characteristics of, the breasts, the wider hips, the fat distribution that would only be there in someone who's like past, puberty. So that's like a general cue, like she's an available individual. But the waist to hip, it's pointing out that the hips are now like wider, most likely not even just in the fat distribution, but also the bone structure. So she can birth an offspring, right? But the waist, the smaller the waist, like I said, it doesn't even matter how small it is in general, whether doesn't matter if she's a size 6 or size 12 or whatever. Is there a distinction? Because the smaller the waist typically on an individual compared to like the hips, the healthier that person is. I think most of us are, when you get a lot of like abdominal fat, especially upper abdominal, it's very unhealthy. There's a very particular way our body, like the fat kind of goes, and the location kind of tells us like the general health of that person. So you might not be thinking, oh, what is the general health of this female I'm looking at? But your mind, evolutionarily, you still have those parts of your brain that are like cueing in on a lot of that, right? So when you see a woman with like a curvy, like hourglass figure, you're probably not thinking, oh, the hips for birthing children. You're just like, I want to put my hands on her waist, right? But in reality, there's like a bunch more going on in the back of your mind. And that's just like one example of how this works. So when we talk about sexual selection being called non-random mating, this is what we mean. It's not random. It's very specific in multitude of ways how this works. So another one on slide 18 you'll see is the facial symmetry is a big one for males and for females. That you'll see, this is an image of Scarlett Johansson, but it kind of looks like her and kind of doesn't. The middle one is an image of her, but the one on the left, the one on the left is the image of her, but the other two photos that follow are her left side and right side mirrored, which, as you can see for her, she still kind of looks like herself. So, her left and her right side of her face look very similar to each other. So she has more facial symmetry. So symmetry, it means like both sides, like left and right, basically look the same. Asymmetrical or asymmetry means there's a bit of a difference. Like everyone has a little bit of asymmetry to their face. Like your one eyebrow is a little lower than the other. You've got a mole on this side, but not on the other side. Like most of us have some asymmetry to our faces. But the more asymmetry you have, typically that kind of maps onto the health, your general health. So you might not be thinking of the symmetry of someone's face outright, but there have been multiple studies showing that when you're just shown, like males or females, when they're shown like images of people and asked to rate them as like attractive or unattractive, the people with the more symmetrical faces are always considered more attractive. And it's because you don't realize you're picking up on it, but you're picking up on like the general health of someone. So if you were looking at that person as like a potential mate, that would be an important factor. Like, right, is this person healthy if I'm going to mate with them, especially as a female, because you're investing a lot of your own energy, resources, time. You got to know it, like, you're going to be able to pick up on a lot of that because it's really important for you to have such a high investment, right? Let's see the next slide 19, facial hair. This is a good one. So another one, multiple studies have been done cross-culturally. Heterosexual females were asked, which of these 5 males, do you find more attractive? And as you're looking at this on slide 19, you'll see the only difference is the amount of facial hair on this individual. So most women, like if you were to number this like 1, 2, 3, 4, 5, most women will select 3 or 4. And usually, even when I ask this in class, most of the female students, even the ones who aren't necessarily heterosexual, will say like, oh, between 3 and 4. Every once in a while, someone will say 1 or 5, but almost always it's 3 and 4. Once again, when you look at a male as a heterosexual woman and you're like, oh, why do you think 3 or 4 is more attractive? You're probably just like, oh, I don't know why. It's like instinctual. I just like it. Or the beard, I like the beard. You might not have a very intricate, detailed way of explaining just why you instinctually find that more attractive. But what we know is that there's a lot more going on evolutionarily. One, the more facial hair, the older. So there's a general, well, whether it's accurate or not, there's a general connectiveness between age and like knowledge and wisdom, which can be important in a mate, right? Mine just went really blank. That's hormonally what's going on, the more facial hair you have. More testosterone, right? Which as a heterosexual, like female mammal, you might be thinking this is going to be important in a potential male partner, especially if there has to be any variant of like protection or something. You want them to be larger than you, right? For protection purposes, which is going to vary depending on the species. But but you don't want to have the one with the most testosterone. So all women, whether we're talking about humans or other mammals, they're not finding the hairiest one the most attractive, because what do we know, especially as females, what do we know about too much testosterone, right? Behaviorally, aggression, right? So it's kind of finding that sweet spot between he's probably a little older and wiser, more mature, hopefully. He's got enough testosterone in his body to kind of have these more masculine traits that I, as a female of whatever species, find more attractive for like protection and all that stuff. But not too much because I don't want to be aggressive with me, especially, or our offspring. So it's kind of finding that sweet spot. But also, we could say culture plays a role because sometimes, beards are really popular. Sometimes they're not. You might find them more in one population than another. So there's the cultural factor for sure. But there's definitely more those like deeper evolutionary reasons. Let's see, how much I'm like, should I just skip all this? I'm like, no, I don't want to skip it. But that's like a long topic. Do I want to get into that right now? I mean, I put it on the PowerPoint for a reason. I guess we'll talk about it. Okay, so slide 20, this concept called neoteny, or juvenilization. We see this in a lot of mammals that, like I was talking about before, about the default, right? The default being the female. And so when you look at the default, state of the species, in most cases as mammals, it's the female, you're going to see a more of a connectedness between what a child or pubescent or adult female look like, and the male is often the deviation from that in multiple ways, right? If we're thinking of like a sexually dimorphic species where the male and female look different, because of course some species of mammals, they're what we call monomorphic. You can't tell the difference between the male and the female unless you like literally look at their genitals. So plenty of species are like that, right? Where like a really good example is like the house cat. You cannot tell unless you look at their genitals. You cannot tell by looking at a cat if it's a male or female, right? It's not like all black cats are male and all orange cats are female. Like that's completely unrelated. Even size, you can see plenty of male cats who are a little smaller, plenty of female cats who are larger. Size is unrelated, right? It's just variation. You have to literally look at their genitalia to be able to tell if it's a male or female. Some species are like that. You cannot tell unless you look. But some species, it's very obvious, right? The males are double the size of the female. The males have all this elaborate coloring and the females don't. The male canines are like 4 times the size of the female ones, like et cetera, right? So when we have that, that's called sexual dimorphism, and there's variation to how that exists in nature. Humans and chimpanzees, as like a primate example, we have what's called a moderate amount of dimorphism. So you can absolutely tell the difference between male and female human or chimp. But like a gorilla is the extreme, where the males are literally double the size of the female. Or so a lot of bird species like the peacock or the peahen, right? The male is the one with all of the elaborate feathers and colors. The female is, a little more plain looking. It's because, like I said before, the males are the ones who have to do all this presentation. The females just kind of be whatever they are, and they're just like, let me pick, which one I like the best. But some species there's no difference, so it's a lot of it's random. But when you have the species where there is a difference between the males and the females, the male is the deviation from the norm. It's the female who's the default state of that particular species. So sometimes we'll see features that you're like, oh, well, in the adult version, the female actually has traits that are very kind of similar to like the juvenile state, which sometimes the male juveniles will have those as well because they're not going to look different. They're not going to deviate from the norm until puberty, right? So in humans, this tends to be like a really big, like think of like a baby, and there's kind of an image here on the PowerPoint, like the top right, you'll see, it's not like a human infant. You just like make it bigger and suddenly it looks like a human. The scale would be way off. We would be like big bobble-headed, people. So like the scale is different, right? You look at an infant, the head is like, a third of the body. The head is massive, the body's small. But as we grow, our head gets a little smaller as like in ratio to like the rest of our body, right? And so when you, as a female specifically, kind of retain some more of those features, like a larger head, bigger eyes, like a smaller mouth, like I think I don't know if I said it right, like larger forehead. Those are typically traits you see only in the juvenile of the species. But when females, like adult females, retain even just kind of a little remnant of that, like they have a slightly larger forehead than another female, a slightly larger eyes than another female, this tends to be considered more of an attractive trait. And I mean, we could talk about this topic for hours, but it all really kind of comes down to something we call paternity certainty. So like imagine this scenario. You are a female, whatever species, and you've just given birth. Is there any doubt that that offspring is yours? No, right? Well, I mean, if you looked at that PowerPoint on like those humorous examples of people being confused about reproduction, some people, even some like a lot of adults still, unfortunately, don't understand that the female doesn't have to do a DNA test. It's not how it works. But the male, even if he's like, we had this wonderful, faithful relationship, say you're humans, right? Or it's like a rabbit and the male's like, well, I've been around the whole time, whatever it is. The male, there's always still, even, 0.0001% chance that maybe it's not his, right? And so paternity certainty, we see this kind of play out in a lot of different species where the male will have certain behaviors, so he can kind of increase the amount of certainty he has that it's his offspring. Because in some species, the male might spend a little more time around the female or the offspring, bringing like food. In some species, this might be for years. It might only be for a few months in other species. So it just depends. But the male's going to want to be a little more, sure, like, am I investing a little bit of my time into someone else's offspring, and this isn't necessarily at the forefront of the mind of a rabbit or, whatever, but evolutionarily, all of that's kind of going on in the background, like in like subconsciously and stuff. And so, for males, one of these things that can help them be a little more, at least they think. It's not really necessarily true in the larger sense, but I guess statistically you could say it could be even a little bit extra certainty if the female is younger. And so for them, like if the female is like post-puberty but still young, there is the chance that I'm like the first to reproduce with her. So it's definitely my offspring, right? That's one way of doing it. And so we see this kind of play out in certain animals, and in other mammals, let's say we see what's called mate guarding, where they're more sure because they're just around her all the time. They're like hovering. They don't ever leave her, and humans, we call that monogamy. So it's going to play out in different species that the male will have different, behavioral strategies of like, how can I just be a little more sure? And, some species, they're like, whatever. Some species are like, okay, I'm going to have a couple of strategies, but it's never really at the forefront of the mind. It's just, you're like, that's just how that particular species behaves. And this is how this one behaves. It's just, so that those two things kind of play into each other. Oh, I was going to make another point. What was it about this one? But kind of think of it this way, though. In evolution, in natural selection and sexual selection, there's often, I think I even mentioned this phrase to you before, running to stay in place. Like we think, when we look at nature, like, oh, look, there's this beautiful balance of everything. Well, it's only a balance because everything's trying to eat each other. And so there's this big vicious cycle, and it kind of looks balanced when you're kind of taking a step back. But in reality, there's chaos to it. It's all it's like chaos might not be the right word. There's complexity to it, It appears balanced and in stasis because everyone's doing the same thing, right? So it's like, so it's kind of the same thing here. One, like a male, whatever mammal might say, and not in the forefront of his mind, but in the back of his mind, like, oh, if I select a younger female, that could even 1% give me a little more paternity certainty. But there's always going to be counter strategies. Like males might think one thing, females are like, well, then what about this? Or this is my strategy to counteract your strategy. And not in like a devious way. It's not even something typically at the forefront of the mind of a male or female mammal. That's just the way it works. Because when we think about our interactions, like as males and females, as humans, we romanticize a lot of it, which is fine. We do that. We're all in love and it's about connection and companionship. And that is true. There's nothing wrong with that. It is true. But there's also other things happening, right? That we don't necessarily, especially as humans, want to admit about ourselves, but we're just another primate, another mammal. And so a lot of the interactions we have as females and males are kind of counter to each other. And a lot of this kind of comes down to the way we reproduce. That for most mammals, males tend to have a strategy of quantity over quality, and females tend to have a strategy of quality over quantity reproductively. There's nothing wrong with that. It's not good, bad, better, worse. There's no judgment on that. It's just the way it is. And it's just because of the way we reproduce. So for a female, because she's going to be doing almost all of the actual growing of the offspring, she's investing insane amount more than the male of that species. So she's got to be a lot more picky and choosy typically with the mate she is selecting, right? So it's more of a quality over quantity versus the male. It's usually quantity over quality, because a male could, let's say a male mates with 100 females in a year. that male could end up with 100 offspring, maybe even more if a couple of them have twins, right? He could end up with 105 offspring at the end of that year if he mated with 100 different women. But if a female mated with 100 different men in the same year, how many offspring could she have? Probably one, maybe two or three if she got like twins or triplets, right? So the investment is different because the outcome is different. So like I said, it's not good, bad, better, worse, moral, immoral. Like that's not even, that's like not even what we're talking about. It's just the strategies are very different. And so of course, like the behaviors associated with it because of the outcome are going to be a bit different. So that's all this really means, you know. We could have a secondary conversation about how these nature processes play out in human culture. That's a whole interesting other topic. And if we were in class together, I would ask you guys to comment and stuff like that, but not quite the same setting. But you can already imagine in your mind, you probably have interesting questions and thoughts about this. It's all very interesting. Okay, so slide 21. This is in reference to these very famous like t-shirt experiments. So actually, let's see what's coming up next. I'm like, where am I heading with this? Okay, that makes sense. Okay, so females were given a bunch of basically white t-shirts in different baggies. It was like like a large Ziploc bag. There was a t-shirt. They opened it up. They smelled it, and they had to rate at some level if they found just the smell attractive or unattractive. That's all they had to go on. They didn't know who wore it, if it was even a man, if it was even a human. They had no idea if even anyone had worn it. They had no idea. So, you know, they were completely blind as to that. And they rated them like, oh, attractive or unattractive. What they had no idea what was going on in the background of the study is that human males, were asked to wear a t-shirt for, I think it was like 24 hours or 48 hours or something. They weren't allowed to use any kind of like deodorant or cologne or anything like that. It had to be just like their natural scent. And females were rating, you know, whether they didn't know anything about what was going on in the background. And so what they found out, though, the researchers, was that the females, because they collected for the males and the females, they collected about a lot of background, like medical data on them. What they found out was the females, in terms of, you know, which smell they found more attractive, they were selecting males with what's called a different MHC or major histocompatibility complex than they had. Basically, this is a reference to like the immune system. You may have heard of, this is a lot of information, but it's all very interesting. You may have heard of something called hybrid vigor or hybrid vigory. And if you're like, I don't know what that is, you probably understand the concept. The idea that like when you're looking at dogs, the ones who are mutts are healthier, purebreds aren't as much. Basically, this is true in nature. The more variety you have genetically, so the more of a mutt you are, the more healthy you are because your immune system is more varied. So it has the ability to sense and attack a lot more stuff than an animal who hasn't had that variability. So that's the same thing with like dog breeds, essentially. Really any animal. So the same thing, the females, just based on smell, were sensing that the other individual had a immune system that differed from theirs. So if they were to have offspring, their offspring would have a very varied and therefore very healthy, essentially, immune system, you know, for the most part. And so it's like, okay, this isn't really a pheromone thing. What is going on? They didn't see who wore these. They had no idea if it was even like anyone had worn the shirts, if it was a male human. They had no idea about any of that. So obviously we as female humans can pick up on something and just scent. You know, I know I am, and I know a lot of females are like this, like the way a man smells. Like as a heterosexual female, you're like, ooh, there's something about like a certain maybe cologne. But even when they're wearing nothing, it's just like their natural, like manly musk. You know, you're like, I don't know, there's something about it. And so obviously there's something going on that we're picking up on, which is why we might like the natural scent of someone and not someone else. Like there's something going on super complex in our brains about like their immune system and stuff. So very, very interesting. Slide 22, ovulation. So ovulation is like the releasing of the egg, right? Now, when you're young and you have your first period, it's about a year between having your first period and having your first ovulation. So you don't ovulate right away. So I think, say your average time of starting your period is around age 12. You don't get your first ovulation till about age 13. There's a bit of a difference, right? But in humans and some other species, but in humans, let's say as an example, because, you know, we're talking about us a lot, I went on my brain broke. Oh, we can't tell. Males definitely can't tell when they're looking at us. Even most of us as females, we can't really tell when it happens. Like some females will say, oh, I feel like there's a little bit of a pinch or a twinge. Most females say, I don't even know when it happens. I don't feel anything. They have to do like an ovulation test if they want to know if that's something they're interested in knowing because they're trying to like have a baby or something. Most of us, we can't tell. It's called, in humans, we call this like concealed or hidden ovulation. But in a lot of other primates, so, we're primates, in a lot of other primates, there's a very obvious like visual swelling. So you'll see here in the image on slide 22, the female has this very large vulva swelling. The whole area, the vulvar area gets very engrossed in blood. It swells up. From afar, right? The males are like, I can see that from afar, let alone close up, right? It's a very obvious visual symbol to everyone. I can reproduce at this point. This is the prime time to be able to reproduce. So the males are like, perfect time, let's mate. So it's kind of a very visual system for them. But in humans, we don't have that. Now, this happens a lot in nature, that you might have a trait evolutionarily that starts for one reason, but kind of gets co-opted or useful for a whole other reason evolutionarily. And so you see this happens all the time. And so, sorry, I got like an itch. So in humans, when we in our lineage became bipedal around 7 million years ago, there literally wasn't room to have, like as a quadruped, sorry, my hair, you could have a swelling of even a vulva swelling. If you're a quadruped, it's kind of towards the back, right? Like in the image. So you can still walk around. It's not really getting in the way. But as biped, if your vulva was large and engrossed and swelled, how are you going to walk? It's non-functional. So hidden ovulation for the human lineage and females started for a very functional reason. It's getting in the way of us moving about in the world. Evolution's like, okay, well, let's just make that a little smaller, et cetera, et cetera. Over time, basically becomes invisible visually. And so then it's like, well, females, like not at the forefront of our mind necessarily, but it's like this, we can end up using this as a really beneficial behavior. It's like, no one can tell, the males can't tell. And so females then can kind of use this to their advantage, especially in humans where, oh God, there's so many tangents. I'm like, I want to talk about it all, but there's so much to cover. Let me see. Okay, I'm going to talk about this briefly because it is very interesting. So there has been this question let's say was in anthropology for a long time when looking at reproduction, males, females, what we do biologically, reproductively, childcare wise, culturally, social, like all of that. The question was, why do we have males? Like, what are males around for? Because it seemed as if for most of the time for us, as a species, females were doing everything. Like we did 99% of the reproduction, right? Males are only there for a brief amount of time. They provide a really valuable amount of genetic information, of course, but the things that we're doing, the roles are quite different, right? So females are basically doing everything after that, and males would be around. But the females were still doing everything like socioculturally, childcare wise. And so this has been a question for a lot of researchers over the years, like, why do men, are they kind of around? Because this idea that they're doing all this like big game hunting, I'd say you're like, if you were thinking, oh, that's the answer, right? They're providing the meat or whatever, that we know historically that's not really accurate. Like men were often doing some big game hunting, and of course there's variation from population to population. That's absolutely true. But females were also doing some of the big game hunting, and females were doing a lot of the small game hunting. The females are the ones keeping everyone fed on the daily basis. What we're realizing, like archaeologically and like culturally, with a lot of the anthropological research, is not always, but a lot of the hunting that males are doing, especially thinking of like deeper time, was often done for like more of a status than actually feeding everyone. A lot of the tools they were making, we like, oh, that was a tool they used to take down an animal, but then functionally, or like this actually wouldn't work really well for killing anything. So like, why were they making these things? A lot of it seems as if it was for like status and stuff, which is fine. It's still a really interesting part of our culture. But it's like a little more complicated than we think of, like, oh, a one-to-one, And so this question, like, well, why are males around? Why do we kind of keep them around? They must be important for something, but it doesn't really seem to be obvious. And then there was this really great study that came out. Oh God, at this point, it's probably been. It's been. I want to say it was in the 2000s, but it might have been in the late 90s. I don't even know now. Hold on. It was like 5 years ago. Let me see. Let me Google this real quick. Oh, by the way, how many of you guys are following the Lindsay Clancy case? It's like, that's all I have on my phone. Like, I'm just like obsessed with it right now. If you have no idea what I'm talking about, because I'm recording these in the summer, so maybe you're watching this later in the fall. Like, if you're not aware, this whole thing is so wild. I mean, I could have a whole lesson on just this case. It's crazy. But okay, what was I gonna look up? Oh, give me just like 1 second. I'm surprised Google doesn't have this because I know I've looked this up before. Come on. Let's see. 2003. That sounds right. Okay, 2000. See, I was right. I was like late 90s, early 2000s. So 2003. This article came out called, I'll write down, The Critical Period of Provisioning. The critical period of provisioning. That barely fit. The critical period of provisioning. And what this is researchers were like, okay, females are doing everything here at this time. They're doing everything at this time. They're feeding everyone here. They're feeding everyone here. Why are males around? There's something we're missing. They must be really important, or at least pretty important for something. And they realized in humans, males are vital in this, what we call the critical period of provisioning. There's a very small but important time frame for a female after, like right around the time she's giving birth, so like right when she's about to like give birth at that time, and for the, let's say, handful of weeks or a couple of months after, where she's at her most vulnerable. Any other time in a woman's life, she's doing everything, right? But there was that critical period where she's like physically and oftentimes like emotionally, psychologically, like not at her highest level, right? Because of the trauma of childbirth. Even in the best case scenario, there's a lot of trauma, like an insane amount of trauma your body goes through. And for those of you who've never experienced that yourselves or seen someone go through it, it is like, we're like, yeah, mammals do it every day. But it's wild, like, and for some women, it's fatal. For some women, it can rob them of so many things about their body. I've known women like their teeth fell out because you think about like the baby sometimes as, like fetally as like a parasite in some ways, like biologically that's because they are taking, nutrients from you. And a lot of times it goes perfectly fine, but in some cases it can be very devastating. So it can often be a very traumatic, even best case, it can be a very traumatic experience for the female. And so there is that time period around that time of birthing, and then after where she's like physically weak and vulnerable. And so that is the critical period where men are like super important, like the offspring's father, like he's there, he's like, I got you, I got the kid, I've got here's the food, because this is when she's at her most weakest. She needs extra food, she needs more nutrient rich food. So he's like, I'm there, right? So he's doing that. That's the really critical period. After that, let's say he's around for those like 3, 4, 5 months, and then he leaves after that, she's probably going to be okay. But that period is very important because that's when she's the most weak. So, and also the child is the most vulnerable. So they need someone else there to be able to like protection and provisioning, resources and whatnot. But also I was talking before about grandmothers. That's when grandmothers come in too. So it's all connected. And so this is when we see, males actually are really, really important, but for this really very important, but very particular window in time. And so the idea of us being like lifelong monogamous in terms of how we understand how mammals work and primates work, we're not really a naturally monogamous species. Because of the amount of sexual dimorphism we have. I feel like I'm getting ahead of myself a little. It's coming up on a slide. But so the amount of dimorphism is directly related to like the social mating system. If you have a lot of sexual dimorphism, so the male is drastically larger than the female, what this means is that there's also a high amount of competition amongst the males. If you have a moderate or medium amount of dimorphism, like the male is definitely bigger than the female, but like it's not a massive amount, you know that there's like a moderate amount of competition amongst the males. And also, if you see a species where they're basically, you can't tell the difference between the male and the female, they're monomorphic, basically the male and female look the same, you know that the competition amongst the males is basically nothing. So those in a monomorphic species, males and females are just naturally pairing up in nature. Don't get this confused. And for whatever reason, every semester there's at least one student who confuses this, thinking if a species is monomorphic, then they're not mating That's not how that works. They are mating. In fact, they're mating for lifelong. They're just naturally pairing up in pairs. Like gibbons are a primate, as an example, an ape species. It's like male, female. They're just kind of finding each other. They're naturally just pairing up, typically for lifelong monogamy. So everyone, basically, every male and every female gets a mate. So everyone's, reproducing. Versus in a species like the gorilla, where the dimorphism is very extreme, males are competing with other males all the time, and a lot of the males don't end up getting access to the females. It's not like, because the males will hoard the females. It's like one male and like 5 females. So there's a bunch of males who never get to mate. And so that's a strong, like, there's a lot, resting on that. Either you get 5 females or you get 0. The competition is insanely high, which is why the males are so insanely big compared to the female. So there's a direct relationship between the amount of dimorphism and the amount of competition going on. I went on like 8 tangents. I was going to relate that back in some way to what I was talking about. Oh, God, critical period of provisioning. Oh, yeah, monogamy. Yeah. So when we look at humans, we are a moderately sexually dimorphic species. We have sexual dimorphism. You can absolutely tell the difference between a male and a female human, which means, and how it works in every other primate and every other mammal, is that the amount of competition the males have amongst each other is a moderate amount, which means we're not monogamous lifelong. We're not lifelong monogamous. Humans are really good at what we call serial monogamy. And most of you have or will experience this in your life. Serial monogamy. So we're really good. Don't let people tell you, oh, we're not naturally monogamous, so I get to cheat all the time. That's not what that means. That's a freaking lie. Serial monogamy, we are very good at that. What that means is we are very good at being faithful and true to one individual in a relationship. Males, females are really good at that. But we tend to have more than one relationship in our lifetime. So you might have, someone you met in high school, you dated for 2 years, you were faithful in that relationship, both of you were, it just didn't work out for whatever reason. You meet someone else in college, you were faithful in that relationship, it just doesn't work out because maybe you have 2 different career trajectories or something. And so you go your separate ways. So we're really good at being monogamous, but just in a series of relationships. And maybe it's your 3rd, or 4th, whatever serious relationship. It's like, okay, this is the one I'm going to stay with for forever, And of course, everyone experiences this differently. You might have found your high school sweetheart and you're together, 50 years. And you might be you might never, settle down. Remember, we talked about this before, that not everything, but a lot of things in life, in nature, fall on what we call the natural distribution, or the bell curve. So when we're looking at, like I said, most things in life, most things in nature, it kind of looks like this, like if we were to graph it, right? And we could say, like I said, not everything, but most things in life or nature. So if we're looking at let's look at some standard deviations, we're like, okay, here, sorry, it's kind of a glare. Let me color this in real quick. We could say the average, if we're talking about this particular thing, monogamy in humans, most of us, the average human, we're really good at serial monogamy. Most of us will have a series of relationships in our life, and eventually we will probably land on maybe 1 or 2 that are really important and last a very long amount of time. So the majority of the bell curve will be filled in with the average state, right? But you will also have, I'm trying to go the